Hello, Tor Lacey here with a lecture about distinguishing among rock types and the rock cycle. Our learning objectives include using texture and composition to identify rocks and the origins of rocks, be able to illustrate the interrelationship among the three types of rocks using the rock cycle, and to be able to physically distinguish between an igneous, sedimentary, and metamorphic rock using texture and mineral content. Three rock types are recognized on Earth: igneous, sedimentary, and metamorphic, each of which form through distinctive geologic processes. Igneous rocks form when lava solidifies on Earth's surface or magma solidifies below ground. The origin for intrusive igneous rocks is miles deep inside the Earth. They are characterized by a coarse-grained crystalline texture, where mineral crystals large enough to be recognized without a microscope are visible. Cleavage surfaces may cause these rocks to sparkle in light. The common rock granite is a good example of an intrusive igneous rock. Extrusive igneous rocks originate on Earth's surface, where lava quickly solidifies, giving mineral crystals only a short period of time to grow before the molten material has solidified. This results in a rock with a fine-grained texture. The most common rock to form in these conditions is basalt. In some cases, the lava may cool so quickly that no mineral crystals grow before the solidification has happened, resulting in the formation of volcanic glass. Sedimentary rocks form on or very close to Earth's surface from minerals and rocks that have been weathered and eroded from pre-existing rocks. Where the eroded rock and mineral fragments, called grains, are deposited then cemented together, clastic or detrital sedimentary rocks form. Clastic and detrital are two technical terms geologists use to refer to grains. Clastic or detrital sedimentary rocks commonly exhibit lamination or internal layering. Sandstone, a rock that forms through grains being deposited and cemented together, is a good example of a detrital or clastic sedimentary rock. Non-detrital sedimentary rocks are generally not composed of grains because they form through a different process, which involves precipitation of mineral matter out of solution, or from organisms, or through the accumulation of organic matter. Metamorphic rocks form when a pre-existing mass of rock is subjected to enough heat and pressure that the original texture and or mineral composition changes to adjust to the new conditions. This typically can only happen deep within Earth, so the origin of metamorphic rocks is always underground. Metamorphic rocks can be distinguished by their common foliated texture or sheen. Gneiss is a nice example of a metamorphic rock with foliated texture. The rock cycle shows how all three types of rock are interrelated and that any type of rock can become any other type of rock. For example, if a metamorphic rock is melted, it becomes magma that will eventually cool and solidify to become an igneous rock. Or if an igneous rock is subjected to heat and pressure, say because it gets caught up in a subduction zone, it will be transformed into a metamorphic rock. We should also recognize that any type of rock can be broken down to become the same type of rock again in the future. Sedimentary rocks, when exposed on Earth's surface, will be subjected to the geologically destructive forces of weathering and erosion. Breaking it down into grains, after these grains have been transported and deposited, they will eventually be cemented back into a sedimentary rock. This illustration here gives us an opportunity to place the origin for the three types of rock in their real-world context and how it relates to plate tectonics. For example, where seafloor spreading is happening along the mid-ocean ridge, magma is forming, which rises up to fill in the gap as the plates split apart, forming igneous rock. This igneous rock can be brought along by plate tectonics into a subduction zone, where that rock itself, or the rock of the crust, is subjected to intense heat and pressure, causing it to be metamorphosed into a metamorphic rock. Magma is formed through subduction, which rises up and eventually will solidify within the crust to form an intrusive igneous rock, or will flow out on the Earth's surface as lava to form an extrusive igneous rock. In either case, the rock here on the Earth's surface will be subjected to the destructive forces of weathering and erosion when exposed. That'll break it down into sediment. Sediment will be transported, eventually ending up in the sea, where it will be deposited in layers and will be lithified into a sedimentary rock over time. This ends this very brief discussion about rocks and the rock cycle. You're going to learn a lot more about this stuff through the videos, readings, and exercises in this module. Thank you for listening.